Modern Plus is a very attractive technology for most of the products out there in the market. So whether it's Google or whether it's Facebook or whether it's any other, I would say big apps. Big apps means big consumer apps, and it may not be social apps like these LinkedIn and stuff like that, but also the enterprise side, softwares which is on data manipulation. So C++ is majority of the backend. So whether it's you talk about image processing in the down, all the unstructured data, I mean the video and the audios, YouTube lying out there. So there's a huge, I would say, big engines which are being written in C++. And I think most of you already know that verticals like gamings and, very critical UIs and sophisticated UIs is already there in C++. So it's been there out and for a long time, and predominantly it's always rating top 3 programming language to work with last 40 years. Something very similar to C, so C and C++ has been there on the top 3 programming language all the while. Yeah, of course, Java took over to be number 1 programming language by usage from 99 onwards, and C, C++, Java, and now we will see even functional programming languages like Python or Scala, try and come up and compete, but and even Golang. So always the advantage of binary compiled language or compiler-based languages are having a lot of advantages over speed, and yeah, I mean that's a little bit about trying to say that C++ is a very rock solid technology to think about extending yourself in your career, and if you know it already, then I think you should be looking to extend it so that you can take the majority of the advantage of C++. So for today, I've just talked small topics in terms of namespaces, which is for your package management. And then we use the overall design principle of an STL. So I like to give you the whole idea of why this has been designed. And then, another powerful concept in C++, which is again, architecture, platform, agnostic concept of concurrency. We have been talking concurrent programming from ages, and we always rely on third-party libraries most of the time. So this time, since C++ 11, there is a huge shift, and this is a good tide for C++ because concurrent programming is designed in a way that it doesn't care about what OS you are on and what's the environment you work on. This is the language specific implementation. So all the compilers guarantee that they will support the runtime, and it becomes a good thing for writing very complex multi-threaded application for which we focus on problem statement and not on the platform specific stuffs. So I think it's giving a huge powerful stuff to the developers. Well, then most of our programs which we write in modern C++ are all about using the programs in switches. And we know all the strong features of C++, basically being very strong type check language and having good support for reference, and a lot of extension like functions. Typically, you can see some of the recent functions which is giving a good competition to functional programming languages like Lambda stuff, and then good packaging concept and a lot of stuff, templates, RTTI, exception handling, the design of decoupling in STL, programming, and concurrent features in C++. Good news is that we have got our own memory model. So, you can influence the way part of your program can be managed by cache line or hardware policy a little bit deeper. So these are some things which are, really, the interesting stuff which is happening out there. And, most of the time, atomics and memory ordering, these are something which is a very recent addition. And, a lot of applications are pretty happy to have these. Of course, you'll see some of the things which are going to come in future, like, writing modular distributed applications. Something what we call it as co-modules. We will be not covering them here. Because usually this is the entire coverage of a C++11. I'm just trying to cut down some of the topics and share it to you. So yeah, that's something which we are covering today. One of them is namespace, and then the STL, and then the concurrency in C++. Now let's start with something like the evolving list, which is coming up. There are just a small glimpse before we get into namespaces that, we are already in 2019, and the whole idea is that it's moving out with a lot of new ISO standards. For example, tomorrow if you have to write for some file system, you write for some network program, or concurrent and parallelisms. These are some things which will be getting added as a part of C++ concept. So what I mean by this, again, these all are standard concepts. So we don't need to think about should I be using a POSIX API, or should I be using an OpenMP API, or should I be using an NVIDIA or something of that sort. And that's the whole aspects of why one should keep looking at the upcoming versions as well. If a language is evolving, it is good for us because it's ready to adapt and change the agility and bring down the agility in the current agile problems, right? So problems keeps evolving, and hence the language. I think that's a good effort which we all are putting in C++, and it's going to be there, it's going to grow. Folks, then now let's get into some of the compilers which we use. I'm going to use here as an Apple's compiler, maybe Clang and a GNU. So most of my examples either will be encompassing to the Clang C++, and then I will also say the GNU CC, so yeah, because very popular, and I have on my box right now. So if you have to, your own boxes, maybe you're on a Microsoft, you can use this version, or any of these should work. Yeah, let's get into the switch standard. This is something very important because modern applications needs compilation with an explicit switch, where we call it as STUD or standards. And 11 and 14 are some examples of the switch. If you do not provide any stuff, then it is referred as, a default stuff. And now this is very important because, you can write explicitly version of specific code in your source code. You can include that saying, hey, if you're a part of 11, then you do this stuff like this. If you're a part of 14, then you could do a stuff like this. And if you're older compilers, then you can do something like this, So how do you use that? There is a keyword called as CPP stud. So notice this example here. And that's something which will give you some unique value of every release value, So every time a C++ is released, it mentions the year and the month where it was drafted at the finalized standards. And if it is growing, it also mentions you the last time environment. For example, here we are trying to set for 17. So it says, when was the 17 finalized? It was here. So these become some unique numbers by which you can include or exclude your actual codes. Now, I maybe, let me share you a small example to show you this up. Let's see it in working. So can you all folks see my command line? Am I visible? Yeah.
Yeah, you're visible, Animesh.
Yeah. So let's take a small example here, which is to C++. And if you can see, is the similar source code which I have presented there, and you want to see how it modes to. So I will say G++, and I was going to say stud C++ 11, and then I'm going to run this program. Standards. You can see on the top, it also shows you the build, if it starts the build. And then, you know, let's check the result. So as you can see, it gives me that it was March 11 when this code was released. And yeah, if you were to try it out on 14, it gives you the February month of 2014. And similarly, you can think if your compiler is 17 compatible, you could also test that. And you know, it should give you 17. I'm going ahead and see if I have the 20th standards, which is yet to come. And it says that, hey, 20 doesn't work with you. Yeah. But there's another way to see the extension. Say some people, you know, so ++2a. And then you can see it says that, yeah, for 2020 standard, the last draft discussion happened July 2017. So it's not progressed from there. And yeah, so it means there will be some more discussions, and the newer updated compilers will give you the newer results. So maybe by 2020 mid, we will have the standard saying that 2020, maybe March or April or June, whenever they decide that this is a new concept which is accepted and it is good to have, and Strastrup gives a go ahead, and then we get that feature involved in, or you know, I mean, incorporated in C++ standards. Now, it's like a hint to the compiler that go on and implement all this stuff irrespective of the architecture. So that's quite a work, you know, but adds a huge advantage for developers to look the modern perspective of the program, you know. So that's something which is about this. Yeah. I hope, you know, why I wanted to introduce you, because most of the examples which I'll be using will be implicitly using this switch. Sometimes what happens is, you know, we use IDE, so you don't mention them. These standards are by default picked up by them, okay? So, yeah. Now let's get into something which is interesting in C++, which is namespaces. And you know, the whole idea of introducing namespace in C++ is to handle very large code bases. When I say very large code base, I'm talking about 50 million lines of source code, 100 million lines of source code. Sometimes Boeing kind of stuff like 1.3 billion lines of source code, or a Tesla, which has the largest code base, 6.7 billion lines of source code. And they are very big and written in C++. And they're working, actually. So, you know, in larger projects, what we always, you know, come across as a problem statement is, you know, we always fall short of the names, you know. So we have some names, and you like a name and I like a name. We all end up using the similar variable names in our modules. And then when we try to combine them all together, then we have problems. So, you know, everybody's crying out there. So what we do is we use packaging concepts. So in 1991, Andre Koenig started this concept of namespace, and he says, hey, let's incorporate this. And, you know, it works pretty interestingly. So let's look at the way namespace works. And, you know, I can take a very simple example here itself, you know. So we can take a code. So let's take namespace.cpp. I'm just going to wipe everything stuff from here. Let me code comment this. We can come this to a later extent. And F. Yeah, folks. Yeah, I'm just creating some space here to do it something from scratch. So, you know, so we got an main here, and Yeah, and what I do is I first and foremost want to write this pretty simple, hello world message. So hello in C++. And another way to write this is Endel. And I'm not using anything over here. Just to tell you that when you write this program, we're expecting that cout to act like being an object. And there is an operator here, left shift, which is an operator, which is overloaded for strings. And then Endel saying that you're going to go for the next line after the print. Very simple. But the moment we want to compile this program, you would see that compiler doesn't know what is cout. It doesn't even know, because see, I'm not giving any hint over here, no header, nothing. So compiler says that, hey, what is the cout? What is cndl? I don't know them. Are they variables? So the moment I say something like int cout, now you see int is an integer variable. And then I'm trying to left shift it by a string. I mean, the compiler says a different error message here. What's interesting out to see, yeah. What does it say? It says that, hey, I don't know Endel, which is anyway the same thing. But now it's trying to correlate some stuff. Hello, sorry, folks. Just got stuck. So what I was trying to say is, I'm just trying to say that just by introducing an integer variable, now compiler started using its head, that, hey, I know there is an integer which can be left shifted. What I mean by this is, if you look at this, very interesting. It says invalid operands to a binary expression. You're using one way int, another is a string, and that's why I'm not going to do this work. So what I mean, if I comment this line, what is? And then I start using cout, say left shift by 2. The compiler is pretty happy. Okay, we aren't doing anything great. But now you can see all the errors is wiped off. Why? Compiler finds a left shift operator to be perfectly legal with both the strings or both the numbers, and compares the string doesn't work, but number is by default available. So it's trying to left shift 10 by 2, actually in this, isn't it? But the moment I enable something like this, now compiler is trying to put his head saying that I can't do this for you because right-hand side is a string and there is no legal rule to perform this job. So this brings it to explicitly mentioning the package you belong from. So now I'm going to do what? I'm going to say, hey, I have something called as IO stream, and I'm going to run something of this sort. And now when I run this program, compiler is giving me a different kind of a warning. Folks, look at this, the way he speaks. What does it say? It says, hey, I don't know where is the cout, but he's trying. See, this error is almost same as what previous was, But now he's adding a hint as well. Hey, did you meant stood cout? And stood cout is coming from where? How on this earth, compiler came to know that there is a matching cout operator with a string. That's the header done the job. So if you look at an header, there will be an IO stream, stood namespace standard. Okay, and there these variables are declared. So he's trying to give a hint. This is called as lookup, or we call it as Koenig lookup, which is by default enabled in the compiler. It means the moment you include any namespace objects and the file is available, compiler will look for its matching construct. And if it finds the exact matching, it will replace them. If not, it will just give you a hint. If there are multiple matches, it will give you an ambiguity and say, hey, folks, you decide which one do you want to call. So always, the way to use a namespace resources are using the namespace name itself, which is the package name itself. So in this case, we'll say stood scope school. And again, saying scope stood scope. So what does it mean? It means somewhere in the file IO stream, there is a namespace declared something like this, stood, and you have all the standard declaration, something like this. As you can see, your result is not very important because namespaces are resolved at compile time, just for verification. So, we don't need to write anything on a namespace, stood, not advisable because they are part of standards. What you could do, folks, is that you can make a call to guys, 1 second, hold on, please. Yeah, sorry. Yeah, so, hello in C++ now is more clear because you gave an explicit scoping. So one of the first thing is that you must use the namespaces with explicitly their namespaces, okay? Which by using the package name. By doing this, you will never have any kind of an ambiguity stuff. Now to give you more supporting stuff, we can also use partial. So this is an example of what? Explicit scoping. Must refer this all the time. That's the first guideline. The second is partial scoping. Partial scoping, some of them you want automatically to be, you want to use as a shorthand, and some of them you want explicit scoping. For example, I could also say using is a keyword for letting the scope being visible to the scope. So I can say using stood scope cout. So by saying this, I am only exposing cout. In fact, you can use file-wise also. Let me show you that as well. So the moment you do this, now you do not need to use what? Stood explicitly, because you have already exposed the cout. But you must use this with stood. And if you do not, compiler will again creep you saying that endl is not exposed yet. See, one of the errors that arrived, and error is only related to endl because we didn't use endl with explicit scoping. So the idea of using explicit scoping is to ensure everybody is happy in the project and we keep getting the resultants as expected. Now there's another version to this, which is called as complete scoping or implicit. Okay. Implicit scoping is something like, you can use using namespace stood. The good thing is, that if you expose namespace, it is only within that particular function. Other functions will still have errors. Now, by saying this, you're saying all of them will be implicitly used. See, this is good for practice, folks. Okay, this is good for practice. Shorthand, or you're writing some complex algorithm, you don't want to do typo stuff like stood scope every time in every message. You're doing some heavy IO lifting. Fair enough, you can do that. But when you talk about the production level code, you will not be writing the code like this. You'll be writing the code line number 8. This is number 1. Okay, that's how you should always go. Okay, then you have something like implicit at worst case to be tried out. But this is how a namespace works. Now, namespace can be also created by us. We also, the whole idea is we can create our own namespace. So let's have one package, say OS, and we will have a data, very popular data, say flag variable. And you can declare, define everything inside a namespace, a class or function, template, everything. It's a global scope. Notice there's no semicolon syntactically. And now if I wanted to use something like a flag is to access, I just wanted to print, say, the flag. and L. And as you can see, it says, I don't know flag. But it is giving you a hint, isn't it? Compiler is smart. It knows that there is a flag inside a namespace, and maybe this guy is referring to it, but I'm not sure. Should I use that one? If you want this to access, always use what? OS scope flag, and that should do for you. Compile and also here, folks. As you can see, the value is 1 as planned. Now, sometimes people have an idea of, so now one of the rules which we should know is if you're writing modern C++ code, one of the things which we aren't practicing right now is declaring the global like variables, like the way we used to do in C, something like this. So assume that I also have a flag which has a value, say 100, and that's a global variable. Now this is a serious conflict with the namespace because there are two copies. Namespaces are a global attribute. It means everything is in the global scope. Only thing is you're giving a package name, wrapping them inside. So what compiler will do, it will manage the mangling. Now, if I build, it's perfectly fine. Why? Because I have used explicit scoping. It means both the variables are happy at this moment. But the moment I say, hey, I just wanted to use the flag variable. So the moment you say flag, now compiler will be completely confused because when he looks at this flag, it doesn't know which package to refer. Should it refer to the OS package? Or should it refer to the package, which is a C-like global variable? And it will spin. You'll be surprised right now, there is no worry because this is a localized scope. And the moment I pull this out, it's a very interesting thing to watch, folks. And I place something here, outside. Now things are going to be very busy. Okay. Compiler says that, okay, I know os.flag comes from main. And when you say by default the flag, it comes from the global. Are you getting it? It means I have a flag variable, which is a OS scope flag. And I'm going to say something like using namespace OS. Yeah. So though I've declared a variable, okay, I am now exposing my OS scope. And let's see what compiler does. He really spins now, saying that, hey, you are ambiguous. I don't know. Should I refer the flag to be called from the main? Or should it be from outside? Okay, are you guys able to hear me? I think there is some lag. People are reporting a lag. Okay, not sure.
Can anybody please unmute and let us know whether you're able to hear Animesh clearly, one of the participants, because I think we are experiencing a little bit of a lag, so we wanted to get your input. Guys, maybe Anbu Sarkar, Dinesh, Madhu, Preeti, Rakshit.
Yeah,
Santosh.
it is audible.
It's audible.
Yes.
All right, then I take Anbu's word and we'll move on. Yeah, Animesh, please proceed.
Yeah. So, I was trying to tell you about the way you will have a global variable conflict with a namespace conflict. And to avoid this, we must use what? Explicit scoping rules. So how do I ensure both of them are accessed? Always use the package name. So I will use OS. And for global variables, we have something very interesting here, weird though, okay? You have to prefix something like a scope resolution operator before the global variable. or the resources. Maybe if you had a global function, you could have done the same thing. And that solves, and it's called as anonymous namespaces or resolution. But it can be confusing with anonymous namespace also. So you can think of no name for global resource. Just you need to prefix what? Scope prefix for classic global resources. Resources in the sense I think about all the functions, all the structures, all the data which we talk about. So I'll just put it as data and methods. So it becomes more explicit. Yeah. So let me show the same thing with a function. So assume that, this is very interesting to see if I have a function, say, okay, log some stuff, and it just starts and login quest namespace. And I have one more function, cout, which is a global stuff. And I'm going to say that notice this is not a part of namespace. And I'm going to say is a global compiler function. So the moment we do this, you can see there is no errors. It's a previous compilation. Now we want to call this function here somewhere. Well, let me be here itself calling them. And I'll say, how do I call the function? I just say the log, right? I want to see what compiler does for me. And it says, hey, I can't call the log because there are two versions. One is namespace version and one is a global version. So what do? I say, hey, I meant OS scope log. So that means it's going to call always the global function. I'm just highlighting the result here. Log in OS namespace. The first answer. And if I wanted to call the another one, I could have just said scope log. Syntactically it looks a little weird, but that's how it is. Now you can see we are able to explicitly make a call to what? The global methods also, and the namespaces method also. In fact, to take more and more advantages of this, we also practice something called as nested namespace. Nested namespace can be a part of the namespaces, and you can create sub packages over here. So let's say I'm having something like an RTOS as another package, and it can have one more logging version function. And we can say this is an RTOS namespace. So naturally, to call them explicitly, you can use what? OS scope, RTOS scope, and log function. So the moment you do this, folks, as you can see, you're having a RTOS focus, you're having an OS focus, and you have a global compiler function. So what does it say? We are trying to experience that namespace are global in nature. It solves the problem of multiple definition challenges. It means no matter how large your code base is going to be, we will never fall short of the names. So everybody using the same name, by using an explicit stuff, you can always have an access to it. Pretty simple stuff. But this is what the practice is all about. I can see the developers still not, getting into the mode of namespace. They love writing the codes which are without the namespace in their source code. And for practice, it is fair enough. But when it goes to production level, packaging is one of the very important aspects of the program. So I think that's one. Now, if you have any questions, you can put it in the chat window. Mubarak and Bharat, I will take a minute's break, okay? So that if they have any questions, they can post it, and then we will take it up. So I'm pausing for a minute, and then if there's no question, I'll proceed further. Thanks.
Done, Animesh. Yeah. Guys, you can use the chat window and maybe share questions which you have at this moment. And I have also shared the link for the full-fledged program, so you guys can maybe have a look at it. This is going to be starting in the second week of September. And also the post today's program, you'll be getting the PPTs and the video recordings for the same. This will be shared in the coming week. So until now, if any questions are there which you want to ask regarding whatever has been covered till now, or in general, any doubts which you have about C++ or modern C++, on any of the topics, you can maybe use this. It's a wonderful opportunity because Animesh's expertise over C++ runs a very long time, including his training as well as his working career, which is spanning close to 23 years now. So it's a nice opportunity to maybe pick his brain and get some answers on modern C++ if you have any questions on the same. So leaving the floor open, any questions on chat window, we'll be awaiting the same. Yeah.
Hello. So,
yeah.
Sorry, can somebody share me the question? I cannot see the questions.
Yeah.
So can I take it as a go ahead for the next session?
Yeah, I think so, Animesh. I think we have not got anything. Yeah. So maybe we can move ahead.
All right, folks, let's get to the next. I mean, that's roughly about namespace. There's a lot of stuff we can, keep dive in namespaces, but we have something more to see. So this you saw as a package management as a very interesting stuff for very large code bases. Now we get into the design of STL, which is further interesting. And design of STL talks more about the way you write data agonistic design. So the whole idea was, if you look at the object model, the whole idea of an object model was to have data and methods will be a part of the design. So we used to split the entire object in the data aspects, and we used to have some methods. And these methods are like, you can think of some kind of algorithm. So all the algos which we write, they were meant for only this data. So see, it's very tightly coupled if you look at. This is called as coupling, So what I'm trying to do is I'm trying to actually ensure that these methods will only work on these data. All these, methods are only for this data. Very nicely, you can organize the code like this, by thinking like this. But the problem is, think of the another class type object, which is there. So by, object diagram itself, I want to differentiate that this is also an object, but it's a different object. Again, it's split. So this is say, you can think this is a circle as an object, and it has some data related to circle stuff and some algorithm which is for manipulating those data. And now we have some, again, so you have a rectangle over here out there, and you split that into, again, some data, and some methods. So it's again some methods. And you can think of some algorithm over here out. Again, the challenge is here that, these methods are only going to work for these objects. So I create a class, I have these methods and they're working for me all the while here, you know. Now there is a need for me to have a method, you know, which can talk from here to here. I mean, ouch, this is weirdo. Means what I'm trying to say is like this, there can be several of thousands of different types and they want to talk to each other. So the problem is these algorithms do not apply for this type. You guys are getting this? Very interesting. So object to some extent gives some view via which, you know, we can really bind them together and data directly cannot be accessed, methods can work on them. Fair enough, folks. But the moment you think about, you know, algorithms, now you think that I need a bunch of algorithms. You know, I'm just trying to take, say, how do I draw this? Okay. Yeah. So see, I have a bunch of algorithms which I want to design with. Okay, I don't even know if I can split them and erase the half part of stuff. You know, and then where's the razor? No, I think it's bad. Okay, so I'll take an approximation. Probably a much better line, and say that, you know, I have a half part of this. This is something which is going to be, I'm just trying to give you a view of that. The whole world is full of algorithms. And these algorithms will work on all the different datas. I don't care whether you are a circle or whether you are in rectangle. I don't care, you know. You're an array or you are on something else, you know. So tomorrow, some more, you know. So I don't know who are you, but I want to work on all. Otherwise, so this idea is what I want to segregate. I want to remove the algorithms from the data. Why? Because these are going to be generic algorithms. So whether it is type this or type this or type this, it should be allowed to it. So the whole idea was, let's go back to decoupling, you know. So by decoupling, folks, what we do, we remove the data and the method separate. And they don't need to know about each other to interact with them. So let's have a look at this idea of design in the presentation. So I hope you all can see this presentation now. Yeah. So if you look, you know, the design of STL, that's the same design. It uses decoupling concept. Now, what do you mean by decoupling, folks? Let's separate the data and methods so that an idea is going to be, you know, you don't want to keep implementing the same algorithm on again and again on all the different types of data, right? So let's separate that and have a common function. But then how do you deal with the data? So you store the data separately, and they are called as containers in the design and algorithm, which we talked right now. And then it's going to give you something, what we call it as iterator. Now, this is a very nice design. The iterator becomes mainly a part of the interface between the data and the algorithm. So, you know, algorithm need not know about the data type, and data just need not to be worried about the algorithm, but you should just be aware about the interface which it has to pass. So that's how the design of an STL goes up with. And if you look at high-level design, they provide different containers to store different kind of data. So all this stuff here. Same with iterators and many more stuff. And then a bunch of algorithms, you know, usually there is 105 algorithms which is there as a part of C++ implementation currently. And they all are data agnostic. So I don't need to know about the data types which I'm working on. And I'm not working on the, the containers operation where algorithm. So what container needs to do? Just follow up with an iterator, which algorithm is asking as an input. Algorithm work on those data templates and give you the results. This is a nice design. If you have to work on any stuff, all the containers are designed in the namespaces stood. Okay, and these are like, say, vectors, doubly-ended queue, doubly linked list, set and multiset both are declared over here. Map and multi-map are stored over here. These are some C++ 11 stuff, modern stuff, where you store the data in terms of hash map or hash function. So they are having O of 1 as a notion, which is much faster. Iterators to have all the iterators, core algorithms, and numeric specific algorithms. Functional talks about a callback, contextual changes for an algorithm. It's like a predicate. When you use an algorithm, you come out with the design. So I'm going to talk about some sequential containers, some associative containers, and some other design. So if you look at sequential containers, vector, okay, doubly-ended queue, list, and forward lists are available. And among all, vector is only the one container on C++ which guarantees dynamically allocating array for yourself, but it is only the memory which is contiguous in nature. However, doubly-ended queue, list, and forward list cannot perform that job, nor even any other data structure. Now, because of this computational capability from hardware, vector is always preferred because it is contiguous memory, and the computation bottleneck for modern computers are completely dependent on the heavy line cache architectures. So, and cache loves contiguous memory, and hence vector completes the job faster than any other, data stuff in the sequential container, and is why it's more preferable. However, it doesn't mean that we cannot use doubly linked list and forward list and other stuff. It depends on also sometimes the way your hardware capabilities are available, how large your cache line policy can be, is sequential storage and actually a requirement for our objects or not. So a lot of consideration, but if you're unsure, you should start from them. So to take care of more complex data structures, you have associative containers stored, where we store everything in terms of a height balanced tree. So either you can use a set or a multi-set or map or a multi-map to perform this job. What's the idea for this is, I'll be using a binary tree to store the data so that my search penalties are always guaranteed. It is deterministic. Most of the time when you perform the search, folks, it will be O log n, O, and then I say it is log base 2 of n complexity, which is really very fast. So whether it is insertion or it is search, it performs the job. The idea is very simple. We use some techniques to store the data, So storing the data can happen, by using the default, comparator operator. So set is a read-only data, map is a read-only data. Multi-set and multi-map can also contain duplicates. So depending on what kind of lookup table or associative pair you want, say you want to create a calendar where you want to say, hey, give me the number index for July. So July should be 7. If I give the input as December, I should get a result as 12. If I give input as January, then I should get the result as 1, So this is an example of you're creating a lookup map for month indexing, So every time somebody gives input as a string and you get index out of that saying that, hey, 1 refers to Jan, and you want to do some computation on that. Just an example. Similarly, you can think storing the data always in association needs a pair in terms of map. Set, the key itself acts like a data. So data itself is acting like a key and you cannot edit them. So that's why they are read-only. However, there are possibilities where you can, create comparator operators of your own and can mix, map out of set, vector out of set, and a lot of stuff like that. Even in modern computer, O of 1 is what I say. So now we don't store the data in tree, but we store the data in terms of the good hash function. So a hash function is used to store the data by which you can use the unordered map or unordered multi-map. Same goes with unordered underscore set and unordered underscore multi-set. Again, the same thing, unordered set and map will not have duplicates. Multi-map and multi-set will have duplicates. But here the order of the data is stored by the hash function. Okay. Well, let me show you some powerful aspects of. I've just put a comparison list which can be available as a PDF to you later. You can go through them. The most powerful thing is about seeing how these algorithms work without modifying each other or with modifying each other, or some sorting and merge sequences of algorithm. Very powerful stuff, proven stuff. And to take that, let's try some example. This time I may want to give you some advantage of an Xcode editor. So we can try out some project here. Let me open one more project. So I'm going to go for a command line application build here. I'm saying this as sample C++ code. And I'm just going to create this. I hope you guys can see my screen yet. And yeah. Maybe, I want to write a function here for saying demo, STL design. And be an external void design. So I'm just going to leave main as it is here and just make a call over here to this function. For the definition, I'll have another source code. Okay. And I'm going to use this as a sample STL design. Yeah, let me wipe this all stuff out here. And I'm going to use some very popular header files. So let's take one example for vector. And I'm also going to use, of course, algorithm. I'm also going to use my function where I'm going to demonstrate this algorithm. And maybe I want to show you one small trick of functional, Yeah. So let's take a demo function and void demo function. Yeah, so all this stuff I'll do here. So I want to show you in a very simple example of an algorithm. Say you want to perform something called as copy. Now a copy is an algorithm which takes some input, start address, end address, and sizes. So I need to have a container to do this job. So first I'm going to try with a normal integer, say I list. And I can take some very small element here, and we can say something like this. And I'll also have a destination address here, say temp, itemp list, and I'm going to say this is also element of 5. So how does the string copy works? The whole idea is that I started with a design that algorithm doesn't care about what kind of data you have, as long as it gets enough. So I can say ilist is my starting address, which is my base address, and ilist plus 5, which is going to be my end address, right? And then I'm just going to say, can you perform that job? To who will be my destination list? So I'm going to say, hey, itemp is where I'm looking to have the results for. And tomorrow I want to print this stuff. I can have a print sequence of data. Print array, or maybe I can just do it here itself, folks. So for auto I to item, Now this is a C++ 11 for loop, where it automatically derives the type. So you just give the name, any variable name which you fill, and then colon itemp. The moment you do this, it actually tries to understand that I is going to be what element, So an I++ will automatically become the part of this. So I can just say itemp of I. I can say cout. So I'll start there. And you can see now, compiler looking for popular variable declaration, IOStream. And also looks for using namespace stud. Shows you a hint. So in this fashion, we definitely want to know the result of there is code. You will be seeing here the result coming out. So you can see there is some stuff here. The elements are not being listed very well. Itemp of I is a reference, and probably it just loses all the elements. It should have copied all the elements, right? Though we said it is, I'm using a brace initialization of 11, 33, 55, 66, and 2. So copy was supposed to actually perform 3 iterators. I just want to show you this. Copy. So input iterator first and the last, and the output iterator result, where it will be storing, which is the base address. Okay. Now resultant, can we also perform the initialized all to 0, so that at least what part has been copied and not can be visible. You can see it's overriding the data by performing this stud copy. If I say this to be an IList, you can see the data auto is not able to result you in here. So maybe for I in, it's int I sign 0, I less than, the size is 5, and then plus plus I, and this is an old style. I'll bring you again the container type for auto, and then you can see them. And now I want to verify that with the itemp as well. So as you see, itemp performs a pretty good job. So what we are saying is the copy is perfectly done by the algorithm, and it didn't care about who you are, whether you were an array or something. Now similar kind of stuff is what I want to check it for a vector as well. So I'm going to say a vector. And I'll say, okay, we'll try something like this itself. So V is my vector, and I want to have some numbers like this and something like this. And I'll have one more vector, say again in int, and vtemp, something like that. Notice I have not given the size of them. If you do not give the size, the copy will have undefined behavior impact for it. So again, when I write this copy, say stud copy, and now I'm going to say va dot begin. Now this is an advantage for the containers, they provide basic functionality, APIs name. So va.begin and va.end will have the end address. So you don't need to manually calculate like ILIPS +5 or some stuff like that. And then VT is what you're looking for. Maybe you wanted to print something very similar for an auto list. So I'm going to bring this same here. And we'll try to print this with V. One of the good things is operator like square bracket is overloaded for us. So you can still print, the array with this idea. And you can see here, cannot increment the value of the type array is coming up because we are trying to scalar the problem statement here. This. So how it works here is a little different. We use iterators to perform this job in vector. A classic way to iterator will be to use something like this, I'll say stood vector. You're going to be int scope iterator. And then I will say you are a forward iterator. And any name you can use, this is a general pointer. And then instead of this 0, you're saying fi is equal to va dot, and then you want to go begin. And then you want to always compare while fi, which is an address, is not equal to va dot until you reach to the end of the element. And then you're going to say ++fi. Because a pointer, you will dereference that by saying star fi. This is roughly how you can iterate over a vector, and you might try to print. This is vt.begin. Yeah. As you can see, there is a crash over here, and this crash is coming because I haven't given the size of the itemp here. Not itemp, I mean the vector here, vt. So the very old style is you can say va.size. And I want the program to run over here. As you can see, 12.3 is perfectly copied into this. So what are we learning? That copy algorithm is completely agnostic to the data type. Whether it's vector, whether it is this, it doesn't care. Getting it? So same thing you can perform with another element also. Say I have a map. Now stood map usually takes a pair. So I'm going to say that let's have a map with say in and a string in C++ stood string. And I want to say that there is some lookup table I'm creating. There will be an index related to an IP address. So say 100 refers to 192.168.1.100. So this is going to be actually 1. And like this, you will have some more. So I'll have it stored as a pair. Make this as just say a 200. Here make the IP address as 101, 102, 103, 104. And just make this as 300, 400, and 500. So first I'm going to use the include map. Okay. And now I just wanted to print the map. So because it's a pair, printing a map is very easy. Again, you would say stood map. And then you can say something like int and string is going to be a part of this. And then say map, say LUT. So scope, iterate. And then you're going to say what? LUT. So iterate it. And then you can always say, for, and now you want to print something very similar. So for it is equal to LUT dot begin, while it is not equal to LUT dot end plus it. So keep hovering over the data structure. Map contains two elements, one key and a data. So I'll be printing the data over here by saying maybe some decoration we want to do. And then I'm going to use the first element, which is being it of first. First is the key. And then I give a comma over here maybe. And then we want to go for, let's say, it of second. And then I like to close this. And of course, and then I'll like to decorate a little bit here, folks. And maybe a small message on the top, the map list is here. So you must start from here. And maybe you want to give a slash in here as well, and a slash in here as well. Yeah. Okay, somewhere here. So notice something that you got the map as well resulted. And now what we do is we want to see, does the same copy can also help me do the same job? So what I do is I also declare one more map, which is going to be a temp map. So a temp lookup. And size of the temp lookup is not known. So we want to still perform the copy. So I'm going to say std copy. Okay. And then I'm going to use the map over here. So I would say LUT dot begin and LUT dot end. However, the size of the map is not known and we cannot use map dot size kind of stuff. Here we have a inserter which takes the container itself and then the start address of them, if you see. So I would say inserter, and my first parameter is going to be the map itself, which is the map is a temp LUT. And then I will say temp LUT dot begin, something like this. After this copying is done, I will like to print this map. So I'm going to remove from here and I'm pasting here. Instead of declaring it to have LUT, I will say TLUT. Correct? Because that should have it. If copy was successful, it should work as it is. And that's it. It's working. Awesome, isn't it? So what you're trying to see, that one algorithm copy is working on a very complex data structures like this, like map, or you can work on a vector, or even a basic data, elementary data types like, array. So what are we trying to conclude? The design philosophy of STL is really very, very interesting. This is how it is going to work. So I hope I was able to give you some very basic, understanding about the decoupling logic here, that how algorithm is separated from the data structures. And by using this kind of certain, I would say, special way of designing and using the interfaces and learning about them, we can actually solve a lot of complex problems, isn't it? Yeah. So I'm going to pause it for a minute again and ask if there's any question anybody have. Who have any other question? As we got some, see, these are very interesting thing to look at different aspects that how people see an algorithm as, and about the concurrency, there's one slide which, solves you about all the aspects of concurrency. Just look at a very big picture where you're talking about, uniprocessor architecture, where, you will be finding the CPU and RAM interacting with each, and then, multiple CPUs trying to interact with your RAM, uniform memory access architecture, and then NUMA architecture where, RAMs with multiple nodes will be interacting to each other. So I'm just trying to show you this. And, if you look from the application perspective, see, I'm just taking an example of a Linux box here. More roughly it's the same on other boxes. But when you start up a machine, usually you get a set of daemon processes which keeps running on the line. And these daemons further fork a lot of processes. Forking is a technique to duplicate processes and replace them with the current process image. The very traditional way of creating processes on the boxes on StarNext machine. Living Microsoft, most of them follow the similar principle of project process creation. In fact, even Microsoft is the same principle, but done a little differently. Yeah. So the idea is to understand about the way concurrent model can be designed. So if you look traditionally, concurrent model has been achieved by two concepts. One is a multiprocessing, which is over here. And another is an example of multi-threading. So multi-threading is an example of shared virtual address space. It means the virtual address space which a process is used to represent is shared across all of them. And when you look at multiprocessing, each process has their own address space. And they have a parent-child relationship here. The lifetime of each other does not depend on each other. So even the parent dies, the parent is reaped and the child is connected to other daemons like init process or systemd or some other process. If you look at the thread environment, the application is a little bit different design. It's like you can think of child to a parent comparison. You will see something like an boss and worker model. When I say boss and worker model, we talk about main as boss and workers as the threads. And what's interesting is as long as the boss is working, the threads are working. The boss is home, the thread is home. So because it's a shared virtual address space, you have a huge advantage of memory life, but it also suffers to a problem of distributed computing. So by default, threaded applications are not good for distributed applications or distributed computing, because they do not use sometimes the channel mechanism for communication. Like if you write process mechanism, each processes talk to each other by using some IPC channel, and hence they're by default good for distributed computing. So you don't worry really about which CPU you're working on, as long as you can talk to each other and your data can compute and do the IO activities work. Unlike if you look at the threaded example, the data communication does not require any special functions for communicating. And hence, the tasks or threads can easily interact with each other without any need of them, and hence make them more dependent on monolith design computing. So though you're using a compute by using parallel computing, but you're not being fit for distributed computing. So idea is, like last 15-20 years, what we have been doing is we design the thread in such a way that they also use the same IPC communication channel. So by doing that, what happens is, we make them distributed friendly. So we take advantage of memory loads also, and we also take advantage of computation load advantage. Now what you do is when you write in C++ coming picture, he says, hey, you stop doing that and you use something like stud threads. So gone are the days
where you will say that I'll use a POSIX interface to design an application, or an OpenMP, or a CUDA, or something, you know. So there are several frameworks by which you can write multi-threaded application. And then all of them finally has to be implemented on the platforms also. So you need to be also worried about how the operating system is also abstracting them. And then how natively kernel is going to handle them, you know. So it's a multi-layer approach of an understanding requirement for writing a simple threaded app. This is very, very load sharing. I mean, we have been doing this, and I think we will continue doing this in most of the legacy projects because they already exist and there's no need for them to switch till we find a way that, yeah, it is to be replaced. It will continue working like this. But the idea is for modern applications, for the next generation app, we must have, you know, architecture, platform, and framework agnostic design, and still provide a way via which you can take control of fine-grained computation advantage on a platform. So what C++ is doing again is trying to create a loosely model like this, where, you know, most of the threaded based implementations at runtime will be provided by C++ library, and you will have to forget about whether you work on a POSIX or OpenMP or a CUDA in future. I mean, this is just desirable. As I said, I don't see anytime soon that, you know, it will be replaced. You know, Microsoft have been trying to compete with Unix from a long time, and they have failed miserably doing this job. So I don't see that, you know, that is going to change anyhow soon. But it's a wonderful opportunity for application developer to stop thinking and worrying about too many platform specific stuff and focus on what other application requirements are. You know, a whole idea of this, it's come out very late in C++, we all must admit. Started, you know, almost 9 years back in 2011. But I would say it's a good inclusion to be there. So folks, to write multi-threaded application, there are a lot of threaded libraries supported here. But one of the way which you do is by using a stored thread. So, you know, thread is it's very easy now, you know, to create and, you know, build them and test them over here. So I just wanted to show you a very basic way of, you know, concurrent coding. So I could say thread demo. And next one. And, you know, I'll be commenting this. Yeah, just to use this thread demo. So in two threads, you know, you have a header here, say threads, and then thread specific APIs are available. So there are several ways you can create a thread. One of the simplest way of creating a thread is by using global method calls. Stored thread, and you create an object, say, I want to create a, say, a logger task for a thread. So say a logger object. And here you can pass a logger, okay, function. Task as a function. And what you need to do is have a function, say void, you know, callback kind of stuff. So logger, and then I'm going to use logger task. That's going to be my function. And I'm going to say, here's some stuff, maybe some messaging out. I can say in logger task. And maybe, you know, what we should do is we should while this one for a moment, just to see you a thread. And even a main, which could be a while one. So I can also say, hey, yeah, in main as well, in main, you know, thread. I just want to give something like a tab here. And then we just want to run this program. Okay, typo here, excuse me. Keep falling, I'm forgetting all these semicolons. As you can see, the program is completely, and it's getting stuck also, heavy bleeding of IO. It's causing my system to completely bleed as well. But it's a very interesting way to see that in logger task, and then there will be some main task and then thread. So compute is happening for sure. Given pretty heavy load, I should have not written while one. Sometimes can become crazy. But that's for sure that, we got this program now, which is doing a concurrent stuff. Pretty easy, I don't really need to care about those platform APIs and whether I run on Windows or whether I want to run on Mac or on any other box, it's going to be the same. So I think that's a fair enough way of, you starting up your threads. Now there's some, again, writing rules, like, if you're writing threads, then, you need to understand the model. As I said, it's a boss worker model. So one must, try to do what? I'll try to, kill this system so that, we will have the Xcode once again working in back its heavy bleed. Sorry, of an IO. Trying to stop it. Yeah, just trying to stop this. Stop. Yeah. So yeah, I think I'm back. Let me open this again. So try to, stop the project and close the window. I'm just trying to come back. So I'm going to remove this, while one here. When I run this program, you will see the behavior is not well defined. We don't know what's going to print over here. So it says main thread and logger thread and crashes. The reason is very simple. If of is as if the logger to wait for the child threads to complete, and you do that by using a join. So I just say log dot join, and then now what happens? It ensures that till your child thread has finished the job, main will hang around there. I did maintain a logger, and it's been taken as something log. It's typo mine. As you guys can very clearly see that there is a logger task. Once it completes, then is where the main is going to run /n, give you this result for sure. Yeah, as expected. So joining a thread ensures that you wait for all those threads to complete themselves, much easier. And several ways where you can create threads. You can pass some parameters. So you can also use another way of creating a thread where you can see, say, a sensor task is what you're creating. Call a sensor task, and you can also pass some parameters if you want. And in this case, we are expecting that we'll have a function here. Again, not planning a return type here yet, but a sensor task. And that can take a parameter, say, some data, and some names. And, we can always think of doing some stuff here. So data is equal to data, and what is going to be is string is equal to names. Sandel. And again, you can see the crash program because I didn't care about whom the sensor task. So I must take the ownership for the sensor task as well. So I'll say, hey, tell me when you're finishing. So I'll say join. And then stuff here. In fact, let the message thread be the last line to be printed. So I'm just trying to do that job. So just by doing this, now you'll be able to find the parameter passing schemes, as you can see here. So when given a space, so a little bit of formatter. Yeah, so it's working. You can also use one more style of creating the thread, which is by using the lambda and the member object also. Say I have a thread here, same sensor here, but now instead of using this, I can use a lambda function. Lambda function is an anonymous function, and here you can think of passing parameters, something like this. So some data and some string. Okay, and you can use the definition, and then you can pass something like 103 and something like this also. So this is your lambda function, and here you can specify, maybe I can print the same message here. So an anonymous function which can be passed as a callback. So instead of you writing a callback function on your own, compiler will generate something for you. So let me show you that here as a message. So that's another way where you are trying to create, okay, build has failed as names. So here I haven't used names. Doesn't know what is that name. And as you can see, the result is the same, but we learned a third different way of you creating the thread. Another could be, you could have, say, a class. Okay, my device. And you may have a method, say public method, which you want to have a part of this. So I may have, set device att. And this device attribute may use similar functionality. And here it does what? It has some private data member, say D, which is maybe ID, and maybe I have a string, which is a dev name. And here it says, dev ID assigns to the data, and dev names assigns to names, something like this. And maybe we have a small function here where show data, maybe device data, of course, which is a const, don't want it to be modified. And I'm going to say cout, something like this. And to change the, okay, dev ID to be dev underscore ID, and dev name to be dev underscore name, right? And it should be a function. So close, yeah. So roughly I've got now what? A class. And now I want my thread to perform some jobs like this. So I'll code comment this as well. And I'll create the same stud sensor task now. Okay, but before this, I'm going to use something like an object of this my device. So I'm going to say my device, some evaluation device. So tomorrow I want to create the object of a thread by using this class method. So I want this method to do some setting for these elements because I don't have a constructor right now. I want this method to do this initialization stuff. So I would say a T-sensor takes the address of my device, scope, and the function name is device attribute. Which is going to be like this. And then it's also possible for you to pass the formal parameters. So say 120, and then you can also pass a message eval dev, something like this. But you also need to pass the object address along with it. So you need to say that, which is that eval object, which is, going to be a part of this. Something like this. You might also want to say T-sensor dot, not T-sensor, the object, eval dot show device. And then build them. Okay, left uninitialized, but setter should perform some set of the job. Misstart initialization, both are printing being null. I mean, the example under which how you pass actually an object and how do you pass parameters with an object is also there. So this is 4 different methods and mechanism by which you solve the data. So though I have documented this as a part of your design, you can always look at different ways. I mean, there are several other ways, but these are 4 prominent ways by which you create object. I'm covering right now about another concept called as asynchronization aspects of it. So there's called as async threads, T threads, and trying to create future and promise objects by which you can influence the way an object can be designed and planned. So explicit usage of the constructor to be always performed when you have some device data being not passed or passed. So as you can see, it is a function automatically is cribbing you that hey, you're passing an address, how it could be the eval object address will be off the scope. So when we return back, we may not find the actual object available. So compilers start treating them very differently there, and the object operators will be again undefined because the functions do not come up with the right result. So after you come back from this, should it be a studref or should it be a refer val, all this stuff, so studref passing parameter should be always by a copy. So if you want to pass only the reference, you must explicitly use studref, and a lot of new things which is added as a part of the subtle design. And I think we definitely can look into all those when the program comes to the aspects of these kind of design. So there also we should have the function as say a reference and a reference. So how do you pass a reference? I'm just trying to add. I mean, the list goes on and on. Like this, we can keep building. But as of now, we will keep these challenges for the actual program segment. Where I'm expecting if there are some people who wants to build a career and want to extend the knowledge in the the modern computing aspects, then we will be looking forward for them. Yeah. So build has succeeded and resulted. So, just wanted to give you guys a small overview of this.